Welcome to this explainer, where we are absolutely going to transform your basic textbook understanding of the laws of logarithms and change of base into a gold standard exam-ready execution. Look, if you are preparing for the Cambridge Mathematics examinations right now, whether you're tackling the foundational 0580 or you're pushing through the more advanced levels like 4024, 4037, 4040, and especially if you're facing the notoriously rigorous 0606 Additional Mathematics syllabus, you are in the exact right place. Today, we are taking on the role of the alchemist. What does that mean? Well, we aren't just going to look at raw mathematical facts and formulas. Anyone can memorize those. Instead, we are going to transmute that raw data into perfect, undeniable, full-mark answers. We're talking about the kind of answers that examiners look at and immediately know you've mastered the subject. Okay, so here is our masterclass roadmap for dominating the 0606 syllabus today. We're going to start by tackling the logarithm challenge head-on. Then we'll move into mastering core principles, followed by laying out a very specific, actionable 5-step execution plan. After that, we're diving into the absolute lifesaver, securing method marks. We'll also review the top examiner warnings, literally the exact things graders are begging you to stop doing. And finally, we'll sharpen what I call your evaluative edge. Let's get straight into it. Section 1, the logarithm challenge. Let's really look at why the laws of logarithms consistently trip up so many hardworking candidates. I want you to picture two typical Cambridge mathematics students sitting in the exam hall. Let's call them Alex and Sam. Now, Alex has studied hard. Alex has memorized every single logarithm rule in the syllabus. But when faced with a complex question, Alex just dumps a chaotic mess of equations onto the page. There is absolutely no analysis, no logical flow, just raw facts everywhere. Then you have Sam. Sam is incredibly fast at calculations, but rushes straight to the numbers, completely skipping over crucial command words like show that or find the exact value. So what happens? When the examiner's red pen comes out, both Alex and Sam are losing massive amounts of points, despite the fact that they actually understand the underlying math. Their flawed answers just become a graveyard of lost marks. It's incredibly frustrating, right? And this isn't just an anecdotal observation. This quote brilliantly illustrates the high failure rate straight from the source. The principal examiner reports specifically highlight that knowing and using the laws of logarithms and, crucially, the change of base is one of the most misunderstood areas in all of additional mathematics. So take a deep breath. If you are struggling here, you are certainly not alone. The issue is that it's not just about knowing the formula in isolation. It is about knowing exactly when and how to deploy it seamlessly when the base numbers in your equation don't match up and the algebra suddenly gets incredibly complex. Which leads us to the ultimate question we need to solve today. Why do students find multi-stage analysis and method marks so impossibly hard? Well, it all comes down to a complete lack of a structured analytical framework. Think about it. When a question is worth 5 or 6 marks, you aren't just being tested on that final single number you circle at the very bottom of the page. You're being tested on your cognitive endurance. You're being tested on your ability to link multiple mathematical concepts together without dropping a single negative sign or misinterpreting a base number along the way. Multi-stage analysis totally falls apart when candidates like Alex and Sam treat the problem as a guessing game, rather than treating it like a highly strategic step-by-step operation. Section 2, Mastering Core Principles. To permanently fix the mistakes that Alex and Sam are making, we have to look closely at the assessment objectives specific to Cambridge mathematics. We need to shift away from simply memorizing formulas and start building a robust, unshakable conceptual foundation. We have to introduce a framework that transforms mathematical chaos into clear, logical order. We call this the Peel framework, specifically adapted for complex mathematics. Point, evidence, explanation, link. Your point is identifying the correct logarithm rule for the specific scenario. Your evidence is writing down the explicit algebraic substitution. Your explanation is executing the algebra flawlessly. And your link is connecting that solved value right back to the specific context of the question. Now, before we continue, subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, so the crucial point here is that Cambridge examiners aren't just testing if you know a rule on a flashcard. They are actively testing if you can adapt that rule when the question looks completely different from what you've seen in practice. Let's say you are presented with a logarithmic equation that secretly disguises itself as a quadratic equation. This happens all the time in the 0606 syllabus. A surface-level student sees something like log base 2 of x all squared, panics, and completely freezes. But top-performing students, they exhibit connected understanding. They recognize that hidden structure, they apply the change of base law to align the terms, they use a clever substitution, like letting y equal log base 2 of x, and suddenly, boom, they are solving a simple quadratic equation that they learned back in year 9. That is exactly what we mean when we say you need transferable skills for unfamiliar contexts. Let's compare two really important core principles: systematic analysis versus evidence-based reasoning. Systematic analysis is all about breaking down the raw data. Evidence-based reasoning is logically justifying your next mathematical step. Think back to our Peel framework for a second. Systematic analysis is the point and the evidence phases. It's looking at an equation that has log base 3 on one side and log base 9 on the other side, and systematically deciding, okay, I absolutely must convert this base 9 into a base 3 to proceed. Evidence-based reasoning, on the other hand, is the explanation and link phases. It is physically writing out the specific change of base formula, log base c of a divided by log base c of b, to prove to the examiner exactly why your numbers are shifting. You aren't just doing the math in your head and writing down a new line, you are presenting a bulletproof, evidence-based argument on the page. Section 3, the 5-step execution. Let's see how all this theory builds into an actionable, standardized sequence. This is where we start turning those red marks on Alex and Sam's papers into beautiful green check marks. We are going to implement what I call the mathematics success blueprint, rewriting flawed answers with incredibly strict guidance. If you memorize these 5 chronological steps, you are effectively using the examiner's own blueprint to solve literally any complex logarithm problem they throw at you. Step 1, deconstruct the question. You have to highlight the command words. Is it asking you to solve, to evaluate, or to show that? These words dictate your entire strategy. Step 2, extract relevant data. Identify your starting bases and your target bases immediately. Step 3, select the analytical framework. This is where you pull the exact correct logarithm law from your mental toolbox. Step 4, execute with clear notation. This is where you lay out your working out line by line vertically down the page, ensuring every single equal sign lines up perfectly. Step 5, present with correct terminology. Ensure your final answer matches the specific format requested. If they command you to leave it in exact surd form and you write a decimal, you lose marks. By rigidly following these steps, Alex stops overloading a page with useless facts, and Sam stops rushing past the crucial command words. And this brings up a brilliant point. Getting the math right isn't enough. You must adhere to strict presentation conventions to secure full credit. Proper headings might mean clearly labeling Part A and Part B of your working. Correct terminology means writing your base numbers as clear, tiny subscripts, so your log base 2 of x doesn't accidentally look like log of 2x. Appropriate formats mean giving your answer to 3 significant figures if the question demands it. Clear annotation means writing a brief note next to your final answer like reject x equals -4 since logs are only defined for positive numbers. This level of presentation screams to the examiner that you are a top-tier candidate. Now, stop scrolling. Subscribe to our YouTube channel AC Exams at acexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Section 4, Securing Method Marks. Welcome to the interactive workshop portion of this explainer. This is a highly critical part of our strategy, how to actually capture those elusive method marks when you are deep in the weeds of multi-stage analysis. When you are scanning complex logarithm equations filled with varying bases, your very first move must be extracting the lowest common base to unify that equation. Spotting that lowest common base quickly and accurately is your essential move to unlocking those vital method marks. You really must understand this. In Cambridge exams, the journey is just as important as the destination. The process is where your marks are truly won. In the official Cambridge mark schemes, these are denoted as M1 marks. If you explicitly write out the correct change of base formula substitution, you secure an M1 mark. Even if your brain glitches and you completely botch the arithmetic in the very last step, losing the final A1 accuracy mark, you have still banked points just for showing your process. One of the most common flaws students make here, which costs them those M1 marks, is applying the power rule incorrectly. They successfully bring the exponent down to the front, but they forget to use brackets, failing to apply it to the entire term. By understanding flaws like this, straight from examiner commentary, you train your brain to never, ever make those same mistakes in the heat of your own exams. To help you execute this perfectly under pressure, I recommend using a memory hack. Visualize your procedural steps as a connected, visual story, moving smoothly from raw data to an evaluated conclusion. For logarithms, think of the base number as the physical foundation of a house, and the exponent as the roof. When you apply a change of base, you are literally rebuilding the foundation of that house, which absolutely requires the structural support of the change of base fraction. A great way to build muscle memory for this is to practice speed writing one perfect Peel paragraph. Point, evidence, explanation, link. For a single logarithm change of base step, you point out the clashing bases. You provide evidence by writing the correct conversion formula. You explain the algebraic substitution, and you link it by simplifying that new expression. Doing this repeatedly forces you to automate the process so it becomes entirely second nature during the real timed exam. Section 5. Top Examiner Warnings. Okay, let's look at the absolute worst pitfalls you must avoid, pulled straight from the principal examiner reports. These are the fatal, easy-to-make errors that consistently drag down national averages every single year. By simply being aware of them right now, you are immediately giving yourself an incredible advantage over the vast majority of candidates. This is a massive red flag from the examiners themselves. It highlights exactly how quickly you can lose marks before the heavy calculation even begins. When dealing with logs, confusing terminology usually means mixing up a natural logarithm, ln, with a standard log base 10, log. It also means totally misunderstanding the instruction to express y in terms of x. If a question asks you to do that and you brilliantly simplify the logarithm, but you leave log y in your final answer line, you haven't finished the job. You failed the command. You must define your terms, execute the final inverse operations, and completely isolate the variables exactly as commanded. You need to constantly check your work against these 3 specific, highly common errors. Mistake number 1, forgetting proper format. This often looks like writing down a rounded decimal when the question explicitly asks for an exact fraction or surd. That's just throwing easy marks away. Mistake number 2, terrible presentation. If an examiner is grading fast and they cannot clearly read your base number because your handwriting is sloppy, they will mark it wrong. And mistake number 3, answers failing to match the context given. This is absolutely crucial in applied math problems. If you are using logarithms to solve a real-world exponential decay problem, like calculating the cooling time of a liquid, and your final time variable comes out as a negative number, you have made a mistake. Time cannot be negative. Your final answer absolutely must fit the logical reality of the given scenario. Section 6, the evaluative edge. For our final section, we are going to look at the higher order assessment objectives. This is what truly separates the average candidates from the top A-star scorers. To get this edge, you need the complete mathematics answering system, which boils down to 3 rules that guarantee top marks. Number 1, command word decoding. Number 2, Peel framework application. And number 3, a time management matrix. This matrix ensures you are spending the right amount of proportional minutes on a heavy 6-mark multi-stage question versus a simple 2-mark state the value question. Notice how the examiner's grading framework climbs. You must push past just describing the steps, move into analyzing the alternatives, and finally, arrive at evaluating your entire approach. Level 1 candidates just describe. They just write down a log law on the paper. Level 2 candidates analyze. They correctly apply that log law to the specific numbers given in the question. But level 3 candidates, the ones who consistently score top marks in Igcse Additional Mathematics, they are evaluative. They look at a complex question, see 3 different possible paths to the final solution, evaluate which specific path requires the fewest algebraic steps, thereby minimizing their risk of making a silly sign error, and then they execute that optimal path flawlessly. This evaluative approach is your gold standard. It requires identifying limitations and justifying every single change of base decision with hard evidence. It means fundamentally questioning your assumptions. For instance, assuming that x can be any real number after solving a quadratic log equation, when in reality, the domain of a logarithmic function strictly requires the argument to be greater than 0. When you evaluate your final answers by explicitly rejecting mathematically impossible roots on the paper, you are clearly signaling to the examiner that you have absolute top-tier mastery over this subject. So I'll leave you with this final critical thought to reflect on as you prepare to tackle your very next additional mathematics past paper. Will you rely on just memorizing descriptive rules like Alex and Sam, hoping for the best? Or will you apply this 5-step evaluative framework to completely transform your performance? The The choice is entirely yours. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.